Good morning, Math 8. We're going to try something a little bit different today. We're going to just record based on a Google Doc, or first part is going to be as a Word document. Unfortunately, it doesn't translate very well to Word doc, this particular one, because of all the equations and stuff. So you'll have to just either print off PDF or just handwrite some stuff for this document. Your Google Doc later, we'll go over that too, but that's your assignment for today, the second doc. That one will be more user-friendly for you on a Google Doc. So just a pre-apology for the lack of write-on ability for this assignment, which is good because the first part's just mental math anyway. So why don't you take a minute and just try to figure out what exponent x would have to have in order to make all of these expressions true. Like 100 over 1 is really 10 to the what power? Or 100 over what is really 10 to the first power. So take a minute, pause the video, and think about those four expressions. What value would x have to have? Okay, so the first two should be all right. The second two, maybe not so much. So the first one, 100 over 1 is really just 100. So 100 is 10, and I use this caret key, it's right above the 6 to say exponent. It's really 10 to the what power? And you should know from your perfect squares and perfect cubes we've talked about recently that 100 is 10 squared. So really here, x would be 2. Because 100 is 10 squared. All right, and over here, 100 divided by what gets me 10 to the first power? Well, 10 squared is 10 times 10. So 10 to the first power is just 10. So 100 divided by what gets me 10? Well, hopefully we know that 100 divided by 10 is 10. So here we'd have to have x equals 10. All right. So the next one might start to get a little bit funky for you. Now we haven't talked about x to the 0 power, or what the 0 exponent means. We're going to talk about that today. But it might not be exactly what you think it is. So we're actually going to skip those two problems for now, and we'll come back to them later, as long as I remember to. So the negative exponent table we're going to learn today, our goal is really to figure out, we have positive exponents, right? 3, 2, 1, cool. Our goal is really to figure out what in the world all of these expressions mean. All right, so they're kind of, it's not like they're counterintuitive, but they don't necessarily follow what we know about exponents. So what I want you to do is follow each sequence. So we have exponential form. What pattern do you notice happening here? What is happening from box to box? And just sort of jot it down on the box. What do you think is happening there? Or on your separate sheet of paper, what's happening there? And then down here, how do we get from box to box to box? What's happening here? And here, could you continue the pattern? And then an expanded form. What's happening to expanded form? And can we continue the pattern? And finally, in fraction form, what's happening and can we continue the pattern? Take a minute, pause, think about what we'd put there, and then I'll go through how to continue all these patterns. All right, so exponential form, what's happening as we go from box to box? As exponent was 3, then 2, then 1, then 0. We're subtracting 1 from the exponent. All right, see if I can merge all these cells. Probably can't. Oh, look at that, I did it, cool. I forgot how to do it. Table, oh, there it is. Okay, so now what happens in standard form? What is happening in standard form? I I knew I'd go to another page. When we look at the standard form box, what's happening as we go from cell to cell? Well, 1,000 to 100. How do I get to 100 from 1,000? Well, I can move the decimal point over, or I'm really dividing by 10. Because 1,000 divided by 10 is 100. 100 divided by 10 is 10. So it's 10 divided by 10. Equals 1. And 1 divided by 10 equals 0.1. And 0.1 divided by 10 equals 0.01. And you can sort of see visually what's happening here. Because we've got ones, we've got zeros, we've got decimal points. What's happening? What does it look like is happening? Looks like that decimal point is traveling, because when we divide by 10, and we've noticed in previous grades, dividing by 10 moves that decimal point over. So dividing by 10 moves over to 100. Dividing by 10 moves over to 10. Dividing by 10, we're just losing a whole place value, a whole factor of 10. So, that's our pattern here. I'm going to try to highlight the important stuff in purple. So then what's happening in the next box? Look at that next box, an expanded form. What is happening down here? What do you notice as changing? So here we multiplied by 3 tens. It was 10 cubed. Notice all these first columns are the same thing. 10 cubed is 1,000. Is 1 times 10 times 10 times 10. 10 squared is 100, which is 1 times 10 times 10. And then 10 to the first power is just 10, or 1 times 10. So really what I'm doing is I'm removing a factor of 10. So here, it would just be 1. 1 times nothing. And if I'm still removing another factor of 10, here, instead of just being 1 or times 10, it's actually 1 divided by 10. And here it will be 1 divided by 10 divided by 10. Or, we can write it a little bit differently. We can write it as, bear with me, as fractions. Dividing by 10 is the same as multiplying by 1/10. Alright, so we had times 10 times 10 times 10, times 10 times 10, 10 to the first, 1 times 10, 10 to the 0 is just 1, 10 to the negative first power is 1 over 10, 10 to the negative second power is 1 over 10 times 1 over 10, or I'm going to change it a little bit actually. I'm going to change this one, or how I'm writing it, because it looks bad. And we're going to change it to say 1 over 10 times 10. I wish Google Docs had this nice equation editor on it. It's really beautiful, but theirs is not the same. So, here's our expanded form for that. 1 over 10 times 10. So for 10 to the negative third, we'd really be dividing by 10 again. It would be 1 divided by 10 divided by 10 divided by 10. Or, just take our previous fraction, 1 over 10 times 10 times 10. Alright, so we're seeing that negative exponents do not make negative numbers. Negative exponents actually just make very, very small numbers. So 10 to the negative first power makes something 0.1, and 10 to the negative second power is the same as 0.01, and 10 to the negative third is the same as 0.001, or 1/1000th. All right? And writing those fractions turns out the exact same thing. We notice that we're losing a factor of 10 in each fraction, so you have 1 over 1. And the next fraction, coming from expanded form, is really just 1 over 10. So let's see, 1 over 10. And my next fraction is 1 over 100, and 1 over 1,000. So our numbers started out really, really big, get smaller, then get really, really, really small, but not quite 0. So our negative and 0 exponents don't actually hit 0. All right? So I'm going to end up doing is I'm going to get rid of this whole row. Actually, I'm going to get rid of a few rows. And then I'm going to give you the nice condensed version of this table. That way you have access to the nice looking equivalent table, because I think that might be a helpful resource to see what these basic negative exponents do, just so you get an understanding of what they look like, because there's a lot of common misconceptions about negative exponents. A lot of times people think it's a negative exponent, it's just a negative number. It's probably just -2 or -100, and that's not how it works. Negative exponents actually just make numbers very, very small, and we're going to look at a couple applications of them. It's a bit confusing to do on your own, and I just deleted everything. Hold on, something bad happened. But we're going to do our best with it. There we go. And I think it's going to be okay for you guys. All right. Oh, I had to delete table. That's what I did last time. Pretty gracious. Okay, so here's our nice table I'm going to give you guys. And basically showing you that each of these columns are the same thing. So 10 to the third power is the same as 1,000, which you knew. Expanded form, it's 1 times 10 times 10 times 10. And as a fraction, it's 1,000 over 1. All right? And then the same with 10 squared, which we should already know again is 100, or 1 times 10 times 10, or 100 over 1. In expanded form, we might have noticed that I've been adding in a 1 times here. And really, I only added in that 1 times because really multiplying something by 1 doesn't change it. And if we did 10 to the 0 power, you might think it's 0 because there's nothing there. But really, it's the same as if there's just 1 there. And otherwise, our division wouldn't necessarily work. It'd be 0 divided by 10 or 0 divided by 100. But there is always the multiplication identity being multiplied on there. We do want to always remember that there is, in fact, a 1 right there. I'll put him nice and green so you know he's a good guy. Yeah. So, and then we notice that 10 to the 0 power, when 0 was my exponent, I ended up with 10 over 10, or 1, 1, and 1 over 1. So at 10 to the 0 power is actually just 1. So in our notes, we're actually going to go on our next page, but that's okay. 10 to the 0 exponent, any number with an exponent of 0 equals 1, or has the value 1. So for example, I'll write 3 to the 0 power equals 1. And then I'll write that same exact thing nicely, because we're still getting used to that whole, that caret thing right here is an exponent. So 3 to the 0 equals 1. And that works for any number. I can copy and paste this and be any number I want. There's only one number that doesn't work. And that number is in fact 0. So I'll just real quick say 0 to the 0 power is undefined, like a vertical line slope. So 0 to the 0th power is undefined. We're not going to talk about that really, because it doesn't really matter. It's just some sort of like, just can't do it. Doesn't make sense. Okay. So any number with an exponent of 0 has the value of 1. Alright. So that makes sense. We're there. And that, to be honest, was actually one thing that I never liked about math much as a kid. So if you're still like stuck on that, I get it. I've been there. I really did not like that when I was a kid. 10 to the 0 was 1. But if you think about the multiplication identity of 1 always being there, anything times 1 is itself, it's always in here. It's just kind of implied. We don't talk about it. It's like how this, if you have an equation like y equals x, the slope is 1, even though there's no 1 there. It's always there. So it's that ever-present 1. It's implied, not talked about. So that's basically what it is. That's why it's 1 and not 0. In multiplication, that thing that's always there is the 1. All right. So I'm going to talk about negative exponents. So 10 to the negative first power. I want you to think, how does 10 to the negative first power relate to 10 to the first power? So we're going to have these two columns. How does 10 to the negative first relate to this? Notice any patterns? I noticed that 10 to the first is 10, and 10 to the negative first was 1 over 10, or 1/10. And my expanded form was 1 times 10, and my over here expanded form was 1 over, should really say 1 times 10 if I'm being consistent. Should say 1 times 10. And I'll make that row a little bit wider. There. So 1 divided by 1 times 10. Sorry, I'm being picky. Oh, look at that, change it there. All right, so now does that same thing work for every other negative exponent? Is 10 to the negative second kind of the upside down version of 10 squared? Is there a mathematical word for the upside down version of? Begins with an R. What's that word? It's like fractions. This is the blank of this. It begins with an R. We play hangman at school and it would be really fun, but it would be a nice Wednesday activity. They're the reciprocal. So 1 over 100 is the reciprocal of 100 over 1. So these fractions are flip-flopped. This was 1 times 10 times 10, and this was 1 over 10 times 10, or 1 over 10 times 1 over 10. So 10 to the negative second is the reciprocal of 10 squared. So let's see what we can do here. I'm going to write an equation form. Again, I'm probably going to throw these notes at you so it's easier for you to get it at your home, just because the computers make exponents a little bit difficult. So 10 squared, oh geez. So 10 squared and 10 to the negative second are reciprocals. Which basically means that 10 to the negative second power, I'm just going to flip again, that's okay. Dang it. 10 to the negative second power is 1 over 10 squared. Let's think about that. So 10 to the negative second power, we said that that was 1 over 100, or 1/100th, 0.01. And that 1 over 100 is 1 over 10 squared, which is 100. So it's 1 over 100. All right. Because 10 to the negative second power was 0.01, which is the same as 1 over 100. All right, so that's kind of our last real exponent rule we're going to look at. That negative exponents are reciprocals of positive exponents, and they're also very small numbers. That's really the important point. Negative exponents are very small numbers. Oops. I'm bad at this. Sometimes Microsoft Word is a pain at formatting. But negative exponents are very small numbers. Don't get confused. They are not negative numbers. It's a very important thing to understand. They're small numbers. They're not negative numbers. It's division. It's not really negative. So 10 to the negative second power is still a positive number. It's actually a penny. It's 1/100th of something. It's a centimeter is 10 to the negative second power. All right. So we're just going to get used to those numbers and what they really tell us about realistic situations today. Let's see. Do I want to even do these questions right down here? Yeah, we're going to try these two. So that messed everything up. Hold on. So we are going to look at 3 and 4 and 5. So we're going to do, I'm going to do number 3 with you. And then I want you to try number 4. I don't have the good paper in front of you, but if you have any sort of paper to write it down on, this would be a good thing to write down. So how would you write 10 to the negative 7th as a fraction, a decimal, and standard form? And how would you write 10 to the negative 5th as a fraction, as a decimal, and in standard form? All right, let's go ahead and try those. Actually, before we try those, I'm going to say that instead of standard form, it should be expanded form. My bad. So expanded form. And now try them. Okay, so 10 to the negative 7th. So as a fraction, that would be 1 over, because the negative exponent, 1 over 10 to the 7th. So it's still not 0, it's just a very, very small number. It's 1 divided by whatever 10 to the 7th power is. And let's look at our table. 10 to the 7th power is, I have them down here. It's about 10 million. Where am I? Sorry. So it's really 1 over 10 million. So there's the fraction. 1 over 10 million. Or 1/10,000,000th. So if you live in New York City, you are 1 out of the 10 million people who live in there, or the metro area or something. You are 1/10,000,000th of the population. There are 10 to the 7 people there, and you personally are 10 to the negative 7. You are 1 out of those 10 million. All right? So that's really what this is telling you. The population is 10 to the 7th. You are one piece of that population. You are 10 to the negative 7th. So that's a fraction. Let's do this decimal. I'll put that first, actually. Decimal. So now we have 1 over 10 to the 7th power. So I should be dividing by 10. Now, here's a little trick. You have 10 to the negative 7th power, which really means you have 1 over 10 million. So really, we can think about place value, okay? So that's 1/10, right? So now if we add a 0, it's 1/100th. Add a 0, it's 1,000th. What comes after thousandths is 10,000ths, 100,000ths, millionths. Sorry, I couldn't remember. 10 millionths. So now we are at 1/10,000,000th. And don't forget your place values, because it's a very important thing to be remembering here, what place value we are dealing with. So our decimals are 0.00000001, so 6 zeros after the decimal point. All right. So my decimal. An expanded form. Now we have 10 to the 7th. We have 1 over 10 to the 7th. So what we're really looking for there is 1 over 10 times. So we have 1 10, 2, 3, 4, 5, 6, 7 tens. So 1 over 10 to the 7th power. All right. So give that a try for 10 to the negative 5th. All right. So this is going to look very similar to what we already have here. I'm going to delete the other questions. We're going to do them. Just don't feel like it. You know, kind of cut things out sometimes. So let's see. All right, here we go. So here's question 2. And I'll put these in bold so I can actually tell what the questions are. That's bold and underlined. Bold and underlined. Okay, so instead of 10 to the negative 7, we now have negative 5. So we're only going to have 1 over 10 to the 5th power, which is really 1 over 100,000, or 100,000. All right, so you're 1 out of 100,000. So that's like you're the only person in Waterbury or something. 1 out of the 100,000 people there. It's a bit of an overestimate, but it's pretty close. Okay, so we're 1 out of 100,000 there. And over here, my decimal, I'm going to do the same strategy as before. I know that 10 to the 5th is 100,000. So now my fraction is 1/100,000th. So I'm moving my place value. I think, all right, I'm at 1/10th. Adding a 0 makes it 100th, 1,000th, 1/10,000th, 1/100,000th. So 1/100,000th. It's 2 words, sorry. All right. Then my expanded form is just going to be 2 fewer 10s because I have 1 over 1, 2, 3, 4, 5 tens. All right. So hope that's helpful. The rest of your lesson today is really just trying to get used to the idea of these negative exponents, like what they tell you, and it's a lot of matching stuff. And the matching is going to happen on Google Docs. We're going to skip that for now. I don't want to give you too much in one day, which I've probably already done. That's okay. Like I said, I've said to a couple of you, and I'm going to say it to everybody. If you have a busy day, like your due dates are not super set in stone for assignments, like if you need an extra day, that's fine, like go for it. Like it is what it is. Or if you need to ask questions, please reach out. So this next activity is a matching. I'm actually going to switch over to the Google Doc to do this, so to show you exactly what you should be doing in Google Doc for the assignment, because that's what you're turning in. All right, so we'll head over there. Okay, so this is your assignment for April 29th. And I'm debating adding one more piece to it and just giving you the rest of the week to work on because I'm really pushing the time for the day. So the name might change slightly. So basically your assignment is going to be to follow the exponent rules. So it's going to be a big matching. So in class, I give you a little card sort type of things because I think that's a fun activity, but I don't have the ability to give you cards. So here's our next best thing. So we have 4 exponents. We have 10 to the 5th, 10 to the 0, 10 to the negative 1st, and 10 to the 5th. And in the table down below, you have different things in standard form, fraction form, expanded form, and just an unsimplified form. And your goal for today is going to be to match them. All right, so to put them where they belong. So we'll do the first one for you, and then you can just sort of see how it's done. So for the exponential form of 10 to the 5th, exponential form is given. Standard form of 10 to the 5th is really 10 times 10 times 10 times 10 times 10, which would end up just being, let's see if I look at standard form. All the standard form ones are the first row. So which of these is 10 to the 5th power? Well, 10 times 10 times 10 times 10 times 10 is going to be 100,000, or B. 10 to the 5th is B. Oops, that was the wrong one. Let's rub it out. B. And you're done when you have all 16 of these letters filled in. And I don't know why the text size is weird, but whatever. All right, you're going to do. And then, like, for all these as fractions, and you're going to find the fraction in the fractioner, like which fraction goes to which expression. It shouldn't be that bad because some of them are fairly quick. And you should know several of them. Some of them are even on the previous table on the other page. Like, I think these two are both in the table on the other page. Those should be quick. And that's just a matter of sorting between 10 to the 5th and 10 to the negative 5th. And then, like, expanded form, you want to figure out for my third column, all right, which of these is the expanded form version? So expanded form is all of these. So you have to sort them all. And down here we have unsimplified expressions. So we have a little more difficult. Which of these expressions actually gets us over here? So you're done when all the letters are filled in. All right, so all 16 letters are in the right place. All right, so write the letter. Don't have to write the whole expression or the fraction. To make it easier, I give the letters for you. Hope that helps simplify things on your end. You all have your own copy, obviously, so your name should be in the title already up here. It'll say, like, so-and-so, 429 assignment. Part 2, the real fun part. So measurements are actually really used. They use a lot of powers of 10, and it's part of being in a base 10 system, like the metric system in science use kilograms and millimeters and liters and centimeters and all that stuff. And all that stuff is actually powers of 10. All right, so here's this nice table. We have, let's look at the normal numbers, like 1. 1 is 10 to the 0. There's no exponent. 100 is 10 squared, which has an exponent of 2. 1,000 has an exponent of 3, and is just 1 with 3 zeros. If we were in school, I would give you this as a nice little printout to go in your notes, but we're not physically in school, so this is one thing I recommend having open or making your own little copy of for your math binder if you still have one and use one. Just because it's really cool, and there's some interesting units you'll probably never hear about ever. Like, really, most of realistic stuff takes place between the giga and the milli. Occasionally getting down to microbiology and stuff, you might have micro, LOL, or nano. Like, you might have heard of a nanometer, a billionth of a meter. I have never heard of anything being a picometer or femto anything, but they're still there. And if you have an Xbox, which I'm sure you do, some of you at least, have heard of a terabyte, a trillion bytes of data. So you're going to learn about all the relationship between all these prefixes, tera, giga, mega, kilo, and the math notation, which exponent gets you there, and what that number actually looks like. Like, we're talking about like bytes of data. A terabyte is a trillion bytes. And as you might know, a terabyte is 1,000 gigabytes. And a gigabyte is 1,000 megabytes. All right, which would be 1,000 kilobytes if anyone ever talked about a kilobyte. All right. They might actually just call a byte 1,000, whatever. Anyway, so that's our table of hopefully familiar-ish stuff. And you're going to match the measurements, nanometer, with whatever power of 10 corresponds to nanometer. All right, so you're going to look, where do you see nano, where do you see meter? It's really just looking at the prefix. What is nano telling you about that meter? Is it 10 to the 12th meters? Is it 10 to the 0 meters? Is it 10 to the negative 3 meters? How many meters is a nanometer? And then you're going to put that in words over here. It's something of a, well, it's meter, meter. There's only 2 meter options, so it's either a billionth or a hundredth, all right? So you're going to do that matching. And you're going to do that by actually using the line drawing tool, if I can find it. Yes, okay. So if you just scroll down and have that menu above you still, we are going to do this by either drawing lines, or you can honestly just write the letters in the blanks. I'll give you blanks. We're going to do that instead. because I think it's easier for everybody. You can also draw lines. I'll show you how to do that. It'll be messy, but it'll also be more fun. I always missed in school when they told us that for matching you had to write the letters, you couldn't draw the lines. That was always sad. So a nanometer, if you're deciding that nanometer goes to like 10 to the 12th power, you just write A and I. Fun fact, a nanometer is not 10 to the 12th. A nanometer is 10 to the negative 9th. So it would be J. And let's see, a nanometer. So J nano is 1 billionth. So 1 billionth of a meter. So it's the 4th Roman numeral, IV. These are Roman numerals, right? I hope some of those are really familiar for you. A few football fans out there, at least, who have a Super Bowl. And so they number them. That's pretty much all I use for. So, what you're going to do, you're going to write the 2 letters it corresponds to, J and 4. Or if you really want to get adventurous, you really want to be artistic, you can, I'm not going to stop you, use a line tool. If you actually, I'm not even sure you can use a line tool on this. I don't think you can. Yeah, it won't let you. You're going to have to write the letters. Alright, so it'll be J and IV. I forgot, Google Docs isn't as cool as Microsoft Word, so it won't let you. And you're just going to do all the rest of them, alright? So centimeter, where's centi up here? What measurement is that? Alright? So best of luck with that. I hope it's at least a familiar, semi-doable way to introduce you to what these negative exponents are really telling you about realistic quantities. Alright? Give it your best try.